October the 11th, 1949. While the last piles are still being driven into the site of the Abbey Works, the plan of the bays and shops has taken shape. The central repair shop stands ready. The cooling tower, pump house and water tower are nearly finished. The stanchions of the melting shop are moving south. The conveyors stride across the site. The coke ovens are lengthening. A year later, in the autumn of 1950, at first sight, the shape has not greatly altered. The melting shop is up. The main shop, along which for 3/4 of a mile steel ingots will be rolled into finished strip and plates, has reached its limit. The shape stands. But behind that shape, what, in the 18 months up to the end of 1950, have been the changes. Here is the tippler for home iron ore and for limestone, and beside it, at the end of the sidings, the coal tipplers. If we follow these raw materials along the conveyors that will carry them to where they are needed, it will, for the first time, be easy to see how the layout of the whole development scheme has been planned. From the coal tipplers, coal goes up to the new washery. From the washery, the washed coal goes across to the new coke ovens, which will increase the total output of coke to 15,000 tons per week. The coke is still going on by rail, but the new conveyor will carry it up to a screening plant, and then on again towards the amalgam blast furnaces. Halfway along this stretch, the coke conveyor is joined by the ore and limestone conveyor. Along this conveyor, up to 400 tons an hour of home-produced ore and limestone will be brought, all for the amalgam blast furnaces. Here at the last bend, where the conveyors divide again, ore and limestone go up into hoppers, and the coke conveyor straight through on the level to the bunkers beyond. All this speed up in the flow of raw materials is to supply new and larger blast furnaces. In October 1949, the new number 2 blast furnace was already taking shape. Number 1 had been rebuilt 3 years before. 9 months later, in the summer of 1950, number 2 furnace was being fitted with its water cooling system. The hearth of this new furnace is 25 foot 9 inches across. The hot blast manifold was in place. The bells, which prevent gas from escaping when the burden of raw materials is loaded through the top, had been fitted, and the superstructure was getting a coat of paint. The conveyors will be ready to bring the raw materials, from which the blast furnace will produce molten iron. But iron ore from overseas will also be needed. The first of 3 new unloaders and transporters for dealing with seaborne cargoes of iron ore is being built. It too was ready by the autumn of 1950. And below it, the wharf had been extended to take bigger ships. The ore will be there for the new furnace. While the system of conveyors and hoppers is being completed, the flow of raw materials to the existing number 1 and number 3 furnaces must not be broken. But in the autumn, the old hoist, which for years brought them up by the wagon load, gives way to the conveyors for the coke and transfer cars for the ore and limestone. The raw materials are there to feed the new furnace. The burden is in. The cars keep moving. The blast is turned on. The raw materials keep coming. November the 9th, 1950, number 2 blast furnace is in operation. so the metal begins to flow from the latest and largest blast furnace in Britain. Much of the iron from the new blast furnaces will, in the end, go back along the railway tracks from Margam to the new melting shop at the Abbey Works for conversion into steel. Below here will be the mixers, into which the hot metal from Margam will be poured. The metal from the mixer will be transferred by 75-ton ladles into 8 200-ton steel furnaces, 4 of which can be seen here. In the summer of 1950, bricking of the first few furnaces was well on the way. Beyond the furnaces are the bays for handling the other raw materials, such as scrap, which will be melted together with the iron into steel. Up this ramp, trainloads of scrap will come. And already the stocks of scrap are being laid in. But until the Abbey melting shop is ready, the melting shop at Margam is supplying steel ingots for the Abbey mill. Here is a train of ingots passing the washery, travelling back the way the conveyors came, alongside and across the road from Margam to Abbey. This is a 90-ton diesel-electric locomotive shunting the train. Now the ingots near the ingot stripping bay, first stage in their 3/4 of a mile journey, which in the end will convert 20-ton steel ingots into 600 yards of strip, 1/10 of an inch thick. But unlike the scrap for the melting shop, these ingots are not simply being stocked until the mills are ready. They are being taken to the soaking pits for reheating. This is the second great change that has taken place in 1950. Part of the Abbey rolling mills is ready for work. The slabbing mill can begin to earn its keep. This is what has been happening. The autumn of 1950, the soaking pits were almost ready. The last bricks were going in. There are 20 of these pits capable of handling 25,000 tons of ingots a week. Below the pits, the last of the flues for the 20 furnaces were being completed. All down the line of the mills themselves, throughout 1950, machinery was coming in. Onto specially prepared boats, ready mounted in the foundations, every piece of machinery must be lowered exactly. The position of each of these boats must be right to within 1/16 of an inch in any direction. When the whole 60 or 70-ton casting is in place, it must not be possible to slide a playing card between it and the foundations at any of the support points. The greatest urgency was to finish the slabbing mill itself, for the slabbing mill could start the useful job of rolling ingots into slabs without waiting for the rest of the mills to be ready. This is the entry table, where the ingots will be carried into the slabbing mill. Here is some of the gearing being assembled. This is the crop conveyor, which will recover the metal trimmed from the slabs. And here is the motor room, capable of taking a load of 4,000 to 5,000 amperes at 600 volts every time the slabbing mill reverses. All over the site, the work is keeping pace. Power is ready. Water. The pump house. The gas mains for the soaking pits. Cranes to handle the great loads. Every one of these cranes has been designed so that even at the most awkward places, a man may stand in safety. And the cold mills, which later will take the hot strip and cold roll it into sheets and tin plate, are pushing ahead. This is the cold sheet mill at Abbey, and this the cold tin plate mill at Trostre, near Llanelli, in December 1949. By the autumn of 1950, the 5-stand mill, round which the whole work revolves, was in place. The palm oil tanks were being completed. The cold mill at Abbey and the coal mill at Trustre will not be needed till after the autumn of 1951, when the hot rolling mills will be running in. But ready they must be as the hot strip begins to come. And now at Abbey, the soaking pits have heated the ingots to 2,300 degrees Fahrenheit. The controls in the slabbing mill pulpit have been tested. The ingots are on their way. The buggy car is waiting to take the ingot up to the mill. The ingot is weighed and turned round, ready for the entry table. When this mill has been fully run in, it'll be capable of slabbing 350 tons an hour. The start of the slabbing mill is the chief symbol of the great change that has taken place in 1950. The development scheme has been translated from drawing board to architectural shape, and from architectural shape to working machinery inside it. The project is beginning to pay its way. So to Port Talbot in South Wales has come a development which will affect all the unnamed people living in these houses for a generation and more. If it had not been for iron and steel, there would have been no Port Talbot. Now its future would be linked with the most up-to-date steel plant of its kind in the world.